Today we are solving ISS 2022 paper 2 question number 13. So consider the following statements. Okay, the statement 1 is this and 2 is this, and which of the following statements given are correct. Okay, so we need to find whether these two statements are true or not. So consider the first statement. The first statement says that for an exponential random variable with mean theta. Okay, so the mean of the exponential random variable is given to be theta, means its PDF is given like this: 1 by theta e to power minus x by theta, x greater than 0. And statement says that n divided by n plus 1 x bar square is unbiased for theta. Okay, so we need to take the expectation of this, and if it comes up to be theta square, then it will be unbiased for theta square. Okay, so for that we need a distribution of x bar square. So we know the distribution of x, so let's write mxt. So I know the form of its mxt is given by like this. Okay, so I always use mxt because there are various two forms in case of exponential and gamma distribution. So it is better if you remember one form and apply the calculation whatever it is. So now mxt, write the mxt, and summation of xi, the homogeneity function of summation xi will be multiplication of this. So this will be 1 by theta t minus n, and m of summation xi by n t will basically be m of summation xi t by n. So we are using the mxt properties here. So it's mxt, basically m x bar t is given by this. So we need to just replace t by n. So 1 minus theta t by n or minus n. Now again rewrite like this. Okay, so now this is in terms of this, which is the homogeneity function of gamma varied with the parameter c and lambda. So x bar is following gamma distribution with parameter a comma lambda. So we need expectation of this. Okay, so expectation of x bar is given by lambda by a, and expectation of variance of x bar is given by lambda by a square, where our a is n by theta and lambda is n. Now put the value. Lambda is n by theta, which is theta. This is n by theta square. We are getting theta by n square. So variance of x bar is related with the expectation of x bar square, which is like this: expectation of x bar square plus expectation of x bar whole square. This should be minus. Okay, so variance of x bar is given by this: expectation of x bar square minus expectation of x bar whole square. Now we know this expectation of x bar square will be variance of x bar plus expectation of x bar whole square. So variance of x bar is theta square by n plus expectation of x bar whole square, means theta square. So we are getting n plus 1 by n theta square. Now we can just like this, n by n plus 1 x bar square. So put the constant in the left hand side. So we are getting this. So our status is that this is unbiased for theta square or not. So we are getting this is unbiased for theta square. So our first statement is correct. Now the second statement is says that for a Bernoulli random variable with parameter p, this is unbiased for p square. Okay, so x is following Bernoulli with parameter p, and this will imply the summation xi, which is supposed that t follow binomial with parameter n comma p. That we already know because of the property. Now this is given our statistic is inverse for p square. So we need to check whether this is inverse for p square or not. So we know the distribution of t. So take the expectation of this. This will be expectation of t square divided by n square. So expectation of t square related with the variance of t, which is like this. Okay, yes, I read it right. Now if t is following binomial, then its expectation given by np and variance is given by npq. Now write this: variance of p and pq this will be n square p square divided by n square. Now solving, we will getting p square by n square. Okay, n square n square, then we have pq by n. So expectation of t square n square is this, which is not p square. Okay, which is not p square, so it is not 1 by square. So second statement is wrong, so option 1 is correct, A is correct.